Thursday, we were trying to work out the duration of a portfolio. So I need present values for the other three pieces. And I said that I would like you to do these while we're gone over the weekend. So when I do the present value of the 10-year bond at 80,000, with a coupon rate of 10%, of a face value of 80 gives me a coupon value of 8. That value, well, wait a minute. That's a nice and easy one. R is equal to J. That bond is at par. 120,000 on a 30-year note with a coupon rate of 5%. 5% of 120 is 6. At 30 years, we have face value of a little over 63.4. This one's at a premium, so we're going to end up paying more than the face value. %15 of 75. It's 15% of 75. 11.25 at 60 years, 10%. What'd you get for this one?
12.3768.
Great. Add all those up and we get our total, which is 347,137.6. If you bought all of those bonds today, that's how much you're paying. It's the present value of everything right now. But that means to do the duration, I need to do the sum that's weighted averaged by the term. So the duration total at 10% requires the duration for each one. But remember, the duration for each one came off of our spreadsheet from the example, and we wrote those durations down last time. So my duration can be calculated by multiplying each present value by the appropriate duration. 1.950 times the 91.3223. The duration on the 80 was 6.759. The duration on the $63 was 11.434. And the duration on the last bond was 10.910. That shifted forward because of how big the coupons are. Add all that up and divide by 347.1376. And that tells me the duration of this portfolio is just under 7.7 years. That's the Macaulay duration. How do I get from Macaulay to modified? Excuse me for a second. Right. So the modified duration is a little bit shorter. I always just divide by that fraction. Question. Duration itself is still a little fuzzy. It's a very odd method of determining risk. But if I have the same cash flows, sorry, if I have different cash flows with the same present value, then I could base my choice of which one I want by the duration to decide whether or not I need more money now or later. And the duration can give me an idea of when the money comes in. But let's suppose I have another commonality that I have the same duration. So these two cash flows in different bonds, different ideas, give me the same amount of money now and the same proceeds over time, effectively, the same net. If I'm going to call these matched in present value and duration. But the term structure could change. It is possible that if I changes, whatever that rate is, because duration is based on a rate, that's why we wrote DMAC 0.10 and DMOD 0.10, whatever changes I get, I'm going to get some reactivity here. But if they're matched in this way, they should react the same. An example. Portfolio 1 is 2 bonds. The first bond has a face value of 50, 2 coupons with a coupon rate of 5% per period. So I'm not even caring whether these are semi-annual coupons, annual coupons, whatever, and a yield of 5%. The second bond is also a face value of 50. It's got 60 coupons with a rate of 15% per period. And a yield of 15%. What's the present value of this portfolio? There's a long way and a short way to do this. The long way is to calculate both present values like this and then add them up. So I have a $50 payoff, 2 coupons at 5% of that. That means each coupon is $250. And I do the 50 here and the 250 here. And they're at 5%. Wait a minute, they're at 5% and 5%. That's at par. When it's at par, it matches out. Aha. That's the short way, is to notice that both of these are at par. So the present value is the redemption value in both cases. So the present value of this portfolio is 100. Now I can go back to the fact that I'm doing 2 coupons at 5%, 5%, and go back to that spreadsheet. I can do the 2 coupons, so 60 coupons at 15%, 15%. And I can get the durations for both of these. The duration on the first is 1.952, and the duration on the second is 7.665. And I got those off that spreadsheet we did last time, which means I can do this idea, and you give me the duration for the whole thing. 1.952 times 50 plus 7.665 times 50 divided by 100 equals 4.8085. Great. Here's portfolio 2. Portfolio 2 is one bond. A face value of 100, 6 coupons, R equals 10% per period. J also equals 10%. Again, that means that the present value, because this is at par, is 100. I don't know the duration of this one, so I'm going to cheat and work it out right now. But I am going to use this oddball formula that we talked about on Thursday here on page 333. So it is 1 plus j over j. J is 10%. 1.10 over 0.10 minus 1 plus j 0.10 plus n r minus j. Wait a minute, r minus j is 0. Oh, n was 6. Put in the numbers. Then divided by R times 0.10 times 1 plus j to the n, 1.10 to the sixth minus 1 plus j. Okay, let's work this out. What do I get when I work this out? Those are pretty damn close, aren't they? Let's effectively say they're the same. They're both 4.8. I want to graph yield rate against number of periods. Page 339. I have this picture. Notice the x-axis here is number of periods, time. Here is our yield rate. As we said, we had 5% at 2 years, 10% at 6 years, 15% at 60 years. The curvature here comes from looking at the book value as we go forward. So if rates change uniformly, what if all of these rates went up the same amount or down the same amount? If all the rates change the same amount, we call that a parallel shift. Okay, realistically, that's a vertical shift in my graph. Huh. If rates went up 1%, then my new portfolio is going to have a different present value because our present value is now not at par anymore. Portfolio 1, we have bond 1 and bond 2, but they now have a different yield. Instead of at 5%, it's at 6%. With a coupon at 5%, but a yield at 6. My second bond, instead of having a 15%, now has a 16%. This is going to change my yield, but not my coupon rate. My coupon rate is still 15%. What is my new present value? Now, since these are part of the same portfolio, you're going to get two numbers. You'll need to add them. Since yields went up, my present value went down. If I can make more money over time, and I know what the future values are, I have to pay less today. What about portfolio 2? Portfolio 2 was a single bond with face value of 100. It was originally at 10%. It'll now be at 11%. It had 6 coupons. It still has a coupon rate of 10%. But a yield rate of 11%. Present value on that portfolio. Well, single bond.
SMA217.
You know, those are pretty close, aren't they? They're less than 20 cents apart. If I've got a parallel shift, then both portfolios experience the same approximate change in value. If I know they have the same present value and the same duration, this idea matches what happens in parallel shifts. I would expect any shift to affect match portfolios uniformly. But if the shift is not parallel, I must recalculate everything. All the present values, if one rate goes up and another rate goes down, let's say we had a flattening of our curve. Here, same page 339, long-term rates went down, short-term rates went up. What's it indicate when short-term rates go up and long-term rates go down? What's that indicative of in the economy? This is an inverted yield curve. I mean, well, it's still normal because it's still going up as we go out, but the fact that it went down here means people are thinking that the long-term future is really good. We don't have to worry about money as much, but in the short term, I need to convince people to give me money right now. So I need to pay better now. So there's a little bit of long-term stability, but there's a little bit of short-term instability. It's kind of a mixed bag, macroeconomic. So what happens here? I got to redo everything. And in a non-flat structure, even matched behaviors, matched portfolios will have different resulting changes. So cash flow series are affected the same way when we have parallel shifts, but regardless of their duration and present value, when we have non-parallel shifts, all sorts of changes can occur. More often than not, markets experience parallel shifts, except in times of upheaval, where we see non-parallel shifts. So it's really going to depend on how we perceive the market. If I consider a cash flow with present value and duration as known as a single zero coupon bond with that present value and that term, this allows us to do a simple calculation. I could say, instead of doing both of these, I could say, oh, it's easier just to consider $100 present value with a duration of 4.8085 and then work it that way. The duration turns our modified cash flow into a single idea. If you perceive rates will go up, if you are betting rates are going to go up, then your risk and a loss in value is more limited in short duration than it is in long duration, because higher rates are given for higher risk. Higher risk means more chance of loss. If I think rates are going to go down, then my risk is smaller or my gain is larger for longer duration. Because I think the rates will go down, I'll be able to make money. Duration can compare volatility of prices, which I think is a useful idea. And it's really what duration was designed to do, to allow us to say, which of these two is going to give me the smoother ride? Because volatility is a problem. Questions? I hope the following sentence is in your head, makes you go, well, no, it is a bad idea to spend money you don't have. Question. Do you have a credit card? Isn't a credit card spending money you don't have? You're taking a loan from a credit company, assuming you'll be able to pay it back when you get paid next, or you're spreading that payment out on purpose. You're spending money that you got from someone else. Somewhere in there, you're assuming, oh, down the line, I'm going to get money and I'll be able to pay this off. So I'm asset matching my future liability. In a good position, I should make investments so that funds come into me, I can spend them, at about the same time that my liability says, hey, you owe us money. My credit card bill shows up. It's got to be paid on December 1st. I get paid on the 30th. Yay. That means my money comes to me and I can send it out to the people to whom I owe money. So I would like to get a good position. At time zero, my forecasted outgoing payments. So I take whatever payment I'm going to owe at whatever time. I bring it back to the present value today. And I call that liability due LT at time T. My electric bill is due the beginning of the month. My gas bill is due at the beginning of the month. My mortgage, my rent, car payment, whatever. I take the present value of that right now, and I call that a liability due. But I can also think of the money I'm going to get. So I have money that's supposed to go out, liabilities. I have money that's supposed to come in. Now, if I am working in a market position, these are bonds, these are stocks, these are sales. But from a personal level, this is my paycheck and my debt. Whatever liabilities I have at a personal level, credit card bills, gas bill, electric bill, internet, whatever, cell phone, all of those things. If I can match my assets to my liabilities for all times T, then I've got exact matchings. I've got a balanced budget. From a personal finance perspective, this is asking whether you are going to run a balance or a surplus at the end of the month. Are you going to be able to pay off your bill in full for your credit card, for whatever items, or are you going to run a balance to the next month? A deficit position or a surplus position? For a business, a deficit position is a problem because it means you owe interest on that deficit amount. A surplus position can also be considered a problem because it means you've got money you didn't put to work. You didn't use that money. You're sitting on it for whatever reason. It could very well be that you need a necessary surplus amount of X percent to maintain your credit ratings. That's one of the federal laws. The university, Seton Hill University, has a committee that looks at the budget and asks, are we in a position where we will run a surplus asset or a deficit position so that we know whether or not we can afford to get better credit rates for next year, for the year after? If we want to build a building, if we want to take a loan to invest in upgrades to the parking lot, to admin, to the dorms, we need to rebuild toilets, whatever it is, I need money to do that. Either the money is sitting in my pocket and I can spend it because I have a surplus, or I take a loan against it because I can asset match against the liability when it comes due. It is to my benefit to do these in discrete units of time where everything lines up to be a common unit of time. So if I have some things that mature quarterly and some things that mature annually and some things that mature biannually or monthly, I'm going to run these back and forth to the smallest unit. It is possible to do this as a continuous idea, to think of a function for A and a function for L, and then instead of all of these sums that I'm going to do, I'll do integrals. So it is possible to do this all in calculus terms. Less common. So I'm going to think of equally spaced times positive integers up to n out in the future. Some of the numbers, AN or AT or LT may be zero. I don't have an asset coming in at this time. I don't have a liability due at this particular time. That's okay. But my goal is to look at the balance behavior. I'm going to lay people off. But my company says that if you lay people off before the age of 65, they get $10,000 a year. And then they get a single payment of $100,000. And then we're done. By the way, this severance package is transferable to their heirs. So if they die at age 64, I still have to make that $100,000 payment. I have to make it to the estate of. This is a fixed set of liabilities. I must pay this. So I need to cover this. I know these three people are getting laid off. I need to cover this so I'll get the money to come in at the right time. I'm going to buy bonds with face value of $100,000 with annual coupons at 10%, because that'll generate the $10,000 every year, which mature based on the ages of the employees. So it turns out one of the employees is 55, one is 53, and one is 50. So I need something to mature in 10 years, 12 years, and 15 years. The one that matures in 10 years will pay the employee who's 55 right now his $100,000 when he turns 65. The one who's 53 will get her payment. And the one who's 50 will get her payment. But it turns out that because I have three different bonds with three different maturities, I end up with three different yields. Now the yield goes up the longer I have the bond, so the 15-year bond has the 12% yield. These are a list of future liabilities. I need to know what assets I need today to be able to offset these future liabilities. That's the cost to me right now. So if I know how much I need in my pocket to do this right now, I can find out, I can cover this. But that's the present value of all of these bonds. Compute for me. Bond one has a face value of 100,000, a coupon rate of 10%, a term of 10 years, and a yield of 10%. What's the present value on this bond? Because it's at par. R is equal to J, we get 100,000. But you could compute it directly, right? 100, 1.10 to the negative 10 plus 10A, 10 years at 10%. That's also going to give me 100,000. Bond 2 has a face value of 100,000. It's got a coupon rate of 10%. It's got a term of 12 years. And it's got a yield of 11%. I'm doing all my work in thousands. That's why I just called this 100 and a coupon of 10. But we're at 12 years and a yield of 11%. And bond 3, face value of 100,000 again, coupon rate of 10% with a time of 15 years and a yield of 12%. This time, which gives me a total asset requirement of 279, 8851. I'm sorry, 8859. So I need $280,000 today to cover not just the $300,000 payments, but all of the $10,000 payments along the way. This is an exact match. This covers everything I need. If I have this money right now, I am absolutely sure that I can fulfill all my obligations in the future. Now, this is a limited set of purchases. I had 3 bonds exactly. I chose to buy these 3 bonds so that it timed out perfectly correctly. I could have lots more options. And quite frequently, we do have a lot more options. Different coupon rates, different maturity dates, different yields, including 0 coupon bonds and non-zero coupon bonds. I might be able to figure this out in terms of stripped items, in terms of multiple bonds paying off at the same time to allow me for multiple ways to build a $10,000 payment 1 year for one of these people. Figuring out the best way to asset liability match to help the company have its cash on hand match what it needs to go out could be really complicated. Things like integer programming, linear programming, simplex method behavior, which is a subset of linear algebra, actually work really well at doing this sort of thing. We're minimizing, in some sense, our deficit. And if I can minimize my deficit all the way to 0, I'll be really happy about that. Questions? This is an exact match. I have exactly the correct amount of money at every single point in time. And we can actually look at this. This first bond pays me exactly $10,000 every year for the next 10 years and then drops $100,000 in my lap. And that's exactly enough to pay off the person who is currently 55. This bond drops 10,000 in my lap every year for the next 12 years and then $100,000. That pays off the person who's 53. And this one pays off the person who's currently 50. Their severance packages are exactly covered 1-to-1-to-1 by each of these bonds. It isn't always possible. Suppose I have, oh, that's barely visible. Let's not use that. That's brighter. I have no liability today, but next year I have a liability of 1, and a year after I have a liability of 1. And I'm going to have a flat term structure of 10%. I'm sorry, that's the yield. And that's a term structure, so that's for 0 coupon bonds. Those are my spot rate ideas. What's the present value of these liabilities? I have a liability of 1 due in a year. At 10%, the present value is 1.1 to the negative 1. I have a liability of 1 due in 2 years. Present value is 1.1 to the negative 2. Total present value. So let's suppose that I say, all right, I want to cover these liabilities. Option number 1. I buy a 0 coupon bond worth 1 in 1 year. I buy a 0 coupon bond worth 1 in 2 years. What's the present value of these 0 coupon bonds? I already know I'm going to end up with 1 in 1 year and 1 in 2 years. This is an exact match. I'm going to use this bond to pay off this liability, and I'm going to use this bond to pay off this liability, and I will be completely covered. This is an exact match. Its present value would be the exact same thing because I'd calculate it the exact same way. Now, maybe I already have these bonds. Maybe these are payments that somebody else is making to me, but I know I'm getting paid one in 1 year and I'm getting paid 1 in 2 years. I know I have a liability of 1 in 1 year. I know I have a liability of 1 in 2 years. The money comes in, the money goes out. Everything's perfect. What if instead I know that the money I have right now is 1.7355 and I have nothing else coming in? Am I covered? Why? So this money is going to earn 10%. Let's think about what happens in a year. 1.7355 earns 10% this year. So this is how much I have at the end of year one. I have to pay off my liability, right? So the money goes out. This money stays in the bank, earns 10%. Round off error. I'm covered. That's 1. If I used more decimal places on the present value and on the asset, I'd be exactly at 1. If this is $1 million payment instead of a 1 payment, then I move the decimal over. I got to come up with 45 bucks somewhere. I won't buy pizza next week here. While this is not an exact match, it is a sufficient match. I know I earn the deposit in a way that works. However, this is not an exact match. It matches at time 0. But at time 1, I have a change because my net assets and my net liabilities are different. Hmm. What's the present value of this series of assets? Aha. I'm not getting any money until year two, so I have to bring it back to today, and that is again 1.7355. Am I covered? Will this set of assets allow me to pay off my liabilities? Well, if its present value is the same, it should. But how do I see this idea? Hang on a second. Here's a timeline. Right? I know I'm going to have 2.1 come in here. That's my asset. But I need to spend 1 here. If I borrow that 1, what interest rate do I have to pay? So if I borrow 1 here, it's going to be worth negative 1.1 there, isn't it? I had to borrow the money. That's a count against me. That's negative. But then I also have to pay out 1 at this time. Look at this. My books balance exactly at time 2. They don't balance at time 0, but they balance at time 2. Matching present value is usually the first step in asset liability matching. Assuming my Assuming that my interest rate stays constant over the times forward, then I have a balanced budget. Surplus deficit is 0. I like this. This is convenient. But it assumes flat term structure, constant interest rates. All right. Let's generalize. Again, assuming a flat term structure, some known interest rate. Some interest rate I0. For all of the times moving forward. And I want the present values to be equal at time 0 using this interest rate. PVA is the present value of the assets. PVL is the present value of the liabilities. Notice I've written liability stream and asset stream. I think of these as discrete income times, but my brain is still thinking continuously. I have this money coming in some regular fashion. I have this money going out in some regular fashion. They don't have to be continuous. So at t equals 0, using I0, PVL equals PVA. All right, wait a minute. Present value of the liabilities is sum LT 1 plus I0 to the negative T. And the present value of the assets is the same sort of sum. Here, T equals 0 to N, T equals 0 to N. I can put that on one side, and I can say that the sum of the difference between asset and liability needs to be 0. That's at time 0. This is equation 7.9 in the textbook on page 342. Sorry, 343. But that's measured at time 0. I could just as easily measure at time n. If I use a different exponent, n minus t, instead of negative t, that's the future value. I'm moving the cash flow forward from time t to time n, rather than moving the cash flow from time t back to time 0. This is equation 7.10, same page. I can think of A minus L as either a deposit or a withdrawal, some sort of line of credit behavior. Like I did in that last version with the borrowing 1 and borrowing 1 and getting 2.1 at the end. The first equation says we start balanced, 7.9. My present value is balanced. The second equation here, 710, says that we end balanced. At the end of all of these cash flows, we are in a non-surplus, non-deficit position. What happens in the middle is the issue now. If I match present values and then there's a rate change, I might no longer have a match. If I match future values and then there's a rate change, I might no longer have a match. So one of the ideas here is that I need to figure out, if interest rates change, what happens to me? What's my position? The 3 examples we did. Part 1, the 0 coupon bonds were purchased at time 0 as fixed rate securities. Changes in rates don't matter. So that was this version. They were 0 coupon bonds. They were bought at 10%. Regardless of what happens to rates in the middle, you still owe me 10%. We signed a contract. In this one, I used this money in the deposit and I waited for it to earn interest. So if the interest rate changes, something might change here. If the rate changes to 9% 1 year through, I'm in trouble for my second liability because I have no other money coming in and suddenly the rate dropped on me. If the rate rises to 11%, I'll be in a surplus position. I'm okay with that. I can cover my liabilities. They won't take me to court. I'm pretty happy about that. What I really want to try and do is to structure my asset income so that at no point in there does my liability value exceed my asset value. I want to structure the cash flows, figure out when things come due, and try and build a setup so that I can make sure I always have money in my pocket to pay my outstanding liabilities. This is not just good professional behavior, this is good personal behavior. How do I build this? We'll talk about that after Thanksgiving break. I did notice when I was looking that I still have 2 days of material to cover. And on our schedule right now, the last homework is due the last day of class. But if I'm going to cover this material on the last day of class, it doesn't make sense for me to have you turn stuff in that day. That's kind of dumb. So I'm going to move the last homework from being due Thursday to being due the following Monday. We don't have class on Monday. So I'm going to make the due time 4 o'clock. And you can come by my office hours, you can slide it under my office door, you can scan it and email it to me, however you want to get it to me. But I'm going to change that date on Canvas for chapter 7, and we're not going to get to the chapter 9 section, so I'm going to scratch that one altogether. I will see you after the Thanksgiving break. Enjoy yourself and have a wonderful time off.